Okay, for this first section, we're going to talk about how to find multiples and factors of numbers. So we are going to do a little bit of talking about how you find multiples, which would be numbers that a certain term can go into. And then we're also going to do a little bit of factoring. So if you guys remember doing factor trees, we'll be talking about doing that as well. First, we're going to focus on multiples. So finding multiples of a natural number. Natural numbers would be 1, 2, 3, 4, 5, and up. Okay, so all your numbers except 0, and we're not dealing with negative numbers. So I first want to go over into like fractions, because sometimes when we're talking about factoring, we have to think about division. And so fractions come from dividing two portions. So a common fraction would be written as something like A over B, like that, where A and B are whole numbers, and B cannot equal 0. So when you have a fraction, the bottom number cannot be equal to 0, because if you try to divide by 0, you're going to get undefined. So we want to make sure that they're whole numbers and that the bottom one does not equal 0, so that we don't end up getting an undefined answer. So the bottom number is called the denominator. And then the top number is called the numerator. So the denominator tells you how many pieces make up the whole unit, and the numerator tells you how many of those parts you're looking at. So the denominator would be like the entire pizza, and the numerator would be how many slices you took from the pizza. Okay, so you're looking at the amount that you took versus the entire thing, how many you started with. Now there's different types of fractions that we can have. The best ones are proper. Those are written in what we consider to be the best form, because the number on top is smaller than the number on the bottom. So for example, like 4/5 would be a proper fraction, 1/4, or like 3/7. Improper fractions is when the number on the top is bigger than the number on the bottom. So like 7/5, 10/5. And that would be, sometimes they are written that way even before they've been simplified. Like we could probably simplify 10/5 to 2. Now a mixed number would be when you have a whole number portion and a fraction. So 2.5 would be an example, or 3 3/5. So anything that looks like that, those would be considered mixed numbers. So a multiple is from that natural number. It's the product of your natural number and another. So it's like you're taking the number that they give you. They're going to give you a number like 5, and they're going to say find some multiples of 5. So you're going to take 5 times 1, 5 times 2, 5 times 3. Do that however many times that they tell you to do in the problem. Or they're going to ask you to show how certain numbers are multiples by writing it as a product of something and being multiplied to something else. So this first one is saying show that 2, 4, 6, 8, and 10 are all multiples of 2 by writing each one as a product of 2 and a natural number. So to do this, you just have to rewrite 2, 4, 6, 8, and 10 as 2 times another number. So 2 would be 2 times 1. 4 would be 2 times 2. And then you keep going. 2 times 3, 2 times 4, 2 times 5. Now, if you're looking to find multiples, that means you want to figure out numbers times your natural number, like what you get. So like number 2 says find 5 multiples of 16. It's going to look similar to what we did, but we're actually going to be doing the right side first to get the answers from the left side. So since they want you to do just 5, I would just take 16 times 1, 16 times 2, all the way up to 16 times 5. So what's 16 times 1? Times 2? Next one? You can either multiply or just add 16 to the number that we just wrote down. Whatever's easiest for you. Next would be what? And last? 80. Good. All right. So we're going to talk next about divisibility tests. And these are useful especially when we're trying to factor something. So you may be familiar with some of these tests, at least especially like 2 and 5 and 10, because those are the ones that are easiest and we probably use them a lot. Like if you know that a number is even, then you know it's going to be divisible by 2. If you know that a number ends in 5 or 0, then it's always going to be divisible by 5. Okay, so some of these rules we know. Some of them you've probably seen before, but you just may not remember. So 2, it's divisible by 2 if the last digit is an even number. That one we hopefully all already know that. To decide if a number is divisible by 3, you have to look at the sum of its digits. That means that you add the numbers that make up the number you're looking at. So like if our number was 125, we would do 1 plus 2 plus 5. And we would see if that number is divisible by 3. So 1 plus 2 plus 5 would be 8. 8's not divisible by 3, so that wouldn't work. 4, if the last 2 digits in your number divide by 4, then you can divide the whole number by 4. 5 is if the last digit's a 0 or a 5. Again, that one's probably one that you guys already know. 6, if your number is both divisible by 2 and 3, so if you go back and you perform the test for 2 and 3, then it's also going to be divisible by 6. 7, there's really not a special test for 7. It can't have a remainder, meaning if you divide, you don't want to have a decimal or anything left over. But there's not like a special test. You would just have to do the division and see what happens. Number 8, look at the last 3 digits. If they form a number that's divisible by 8, then you can do the whole number. 9, again, you're going to add, similar like what we did with 3. You would add the digits together, and if you get a number divisible by 9, then you can. And then 10, the last digit has to be a 0. After that, we don't really have specific tests for like 11, 12, 13, and so on. They kind of just stuck to the numbers 2 through 10. So what we're going to do is look at a group of numbers here. So you guys have some. I'm going to give you guys some time to do this. This gives you numbers, gives you 2 choices, and then it tells you what they're trying to divide by. What I want you to do is write down which number you think it's divisible by, like which one it can go into, and why. Like what's the reason for it. So I'm going to give you guys a couple minutes to fill out that part on your guys' paper there. All right, so the first one, which of these two numbers, 874 or 873, is divisible by 2? Good, 874. Why? Yeah, the last number is an even number. Okay. Second one. Again, 0 would be considered like an even digit. That can be cut in half nicely. How about this third one here? 427? Why? The sum of the numbers is divisible by 3? Because if we take... Are you sure? Should be 423. Because this one, if you add, the sum is 9. You don't get 9 for the other one. You get, let's see, 13. 13 is not divisible by 3. How about the next one? What told you that? Good. The last two digits is 12, and we know that 4 can go into 12. Okay, next one you should have said 80, because that last digit's a 0. And then the next one's 65, because that last digit's a 5. How about for 804, 802? Which one can 6 go into? No idea? 804? Okay, so the reason why for that one, go back to rules for 2 and 3, because 6 says that if 2 and 3 can go into it, 6 can go into it. So 2 can go into both because they're both even. So that doesn't really help us. So 3, we have to add up the digits. So 8 plus 4 would be 12. 8 plus 2 would be 10. 3 can go into 12. 3 can't go into 10. So that would eliminate 802 from our list. Okay, how about 7? Which one does it go into, 58 or 56? Good, 56. That one would just be one you would have to just try to divide out and see what happens. Number 8. So rule for 8 says that the last 3 digits, so you're looking at 160 or 162. Which one is it going to go into? No, not 162. 3,160. Because 160 divided by 8 is going to be 20. Okay. For number 9. No. 477. Again, you got to add those up. If you add those together, you get 18. 18 divided by 9 is going to be 2. And the last one should be 180. Okay, make sure you're using those rules because it really does make it a lot faster instead of just like guessing and checking. Okay, let's talk about finding factors now because dividing is how we get into our factors. So any natural number can be expressed as the product of 2 natural numbers, and those are called factors. Okay, so each number that you break it down to would be considered a factor. So like 3, I could write as 1 times 3. 1 would be a factor, 3 would be a factor. 4, I could write as 2 times 2. So 2's would be factors, and I could do 1 times 4. So certain numbers are going to have a lot of factors. Certain numbers are only going to have a couple. In order to write out your factor pairs, you look at the number that they're giving you, and then you want to start taking it divided by like 1, and then divide by 2, divide by 3, and do as many as you can. And then once you hit one that it repeats something that you already had in your list, you're done. You don't have to keep going and finding more because then you've gotten them all written out. So let me show you what that looks like. So if I want to find the factor pairs of 18, first I would take 1 times 18. Okay, so 1 and 18 would be a factor pair. 2 times what would be 18? 9. So 2 times 9 is the second pair. 3 times 6 would be 18. 4 doesn't work. 5 also isn't going to work. 6 would be times what? 3, but I already wrote that up in my list. So this is when I said you look for that repeating piece. So this repeats, which means that you stop here. Okay, so your factors, your pairs, would be 1 and 18, 2 and 9, 3 and 6. So you guys do the next one. Find the factor pairs for 48. Do exactly what I did. Start with 1 times 48, 2 times, and keep going. Find all the pairs. And I'll give you a hint, you should have 5 total pairs. So you should have had 1 and 48. 2 times what? Can 3 go into 48? 3 times 16? How about 4? Can 5 go in? Nope. How about 6? 8, 7? And then 8, what happens at 8? That's when it repeats, okay? That's where you stop. So your pairs should have been 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Like I said, I've got 5 pairs. So there they are. All right, let's turn the page. So now we're going to get into finding prime factorization, but first we need to talk about what makes something prime versus not prime. So a prime number would be a whole number that's greater than 1, and its factors are only 1 in itself. So it has no other numbers I can divide into it. 1 is not considered to be a prime number. Okay, so anything bigger than 1, like 3 would be the first prime number. Well, 2 would be the first prime number. And then 3, and then 5, and then they keep going. So what we're going to do first is just identify whether or not these numbers are prime or not prime by looking at the factors of the numbers. So for 8, I just think about what would be numbers that would go into 8. So 1, 2, 4, and 8. So I already have more than just 1 and 8 itself, so this would be considered not prime. How about 1? Not prime, okay? I told you that 1 is not considered prime, so that's basically a trick question. How about 3? Prime, because what are its factors? 1 and 3. How about 9? Is 9 prime? So that would make it not prime, because there's 3 factors. Is 7 prime? Yes. So if a number isn't prime, like the 9 and the 8 weren't prime, those are called composite. So composite numbers would be when you have more than just the factors of 1 and the number itself. So again, what we're going to do here is look at a list of numbers. You guys take a minute and do that. I just want you to write down whether you think they're prime or composite. So what did you guys write down for number 1? Composite. I'm just going to abbreviate and put a C. How about number 2? 3? 4? And 5. Good. So what we're going to do now, and kind of to finish up this section, is talk about how to write out something's prime factorization. So that's when you take a number that has multiple factors, like 35, 48, those kind of numbers, and you're trying to find the prime factor. So you're trying to factor it out. So you're going to do a factor tree in order to help us do this. But what we're looking for are those factors that only have itself and 1 as factors, and those are called your prime factors. So this is what we're going to be looking for in these problems. So kind of the way to do a factor tree, if you don't remember, is you look at the number that they give you, you try to find any 2 numbers that go into it. Now if you want, if you know it's even, you could always start by doing 2 times whatever. But if you know that there's bigger numbers, sometimes it can shorten the work for your factor tree, because sometimes if you're only dividing by 2, your factor trees are going to get really long. So I wouldn't say just always go for 2 or 3 or like a small number. But you want to get down to those prime numbers, because once you found them, then we can write out the prime factorization. So for 30, what are 2 numbers that can go into 30? Now when I factor it like this, because this is starting my tree, if I have a prime number, I circle it. That way I don't lose it later when I try to write out all the prime factors. So 5 is a prime number, so I'm going to go ahead and circle that one. That means that I don't need to factor that at all anymore, but 6 is not prime, because what 2 numbers can go into 6? Good, 3 and 2. Now these are prime, so I'm going to circle those. So to write out the prime factorization, we write them in order, and we like them to be written so that the smallest number, and then you do that however many times you need to, then the next smallest, and then up to the biggest. So 2 times 3 times 5. Okay, let's look at 16. What are 2 numbers that go into 16? 4 and 4. And how would you guys break down the 4s? Good, 2 and 2. And your 2s are prime. So I just circle them up. So you could write this out as 2 times 2 times 2 times 2. Or we could do 2 to the 4th. So it's okay, especially if you have a lot of the same number repeated multiple times. Like if you're factoring out a really big number and if you've got like 5 2s, instead of having to write out 5 2s or 2 5 times, just use an exponent. It'll shortcut. Okay, let's do the next one. 210. 21 and 10 would be great. Okay, that would be a lot better than doing like 2 times something, because your factor tree is going to get longer if you do a 2. All right, so what goes into 21? 3 and 7, and what kind of numbers are those? Prime, so I'm going to circle them. How about 10? And again, those are prime, so circle those up. So writing it out would be 2 times 3 times 5 times 7. So the reason why we want to find factor trees like that is to help us find 2 items. One's called least common multiple, and one is called the greatest common factor. So least common multiple is the smallest number that those 2 numbers or whatever numbers you're looking at can go into. So like for 2 and 3, for example, if that was those 2, the smallest number that they could both go into would be a 6. So we're looking for the smallest number that the factors are giving you, or the numbers that they're giving you, could go into. So in order to do these problems, you have to factor out the 2 numbers, or it could be 3 numbers that they're giving you. So you got to find their factor trees, write out their factorizations. Then what you do is you take, it says here, If a prime factor appears in more than one number, use the factor with the largest exponent. So I'm talking about this sentence right here. What that means is if you got two numbers, this one has 3 2 times, and this one has 3 4 times, you take the bigger of the two options. So you take 3 to the 4th power. So if one of them had 5 one time and one of them has 5 3 times, then you take 5 to the 3rd power. You just have to take the most amount of times that you see that factor happening. Then to find the LCM, after you've taken all those factors, you multiply them together to get the number that they can go into. So if we're looking at 12 and 40 here, I'm going to start first by factoring 12 and 40. So 12 I can break down to 3 and 4, and then 4 would be 2 and 2. And 3, 2, and 2 are all prime. So I'll write that as 2 times 2 times 3. Or you could write 2 squared times 3. Okay, now let's look at 40. I'm going to break 40 down into 5 times 8. 5 is prime. 8, I'm going to do 2 and 4. 2 is prime. And then break down 4 to 2 times 2. So I have 2 3 times for this one, and then a 5. So to find the LCM, the least common multiple, we take the most amount of times that you see a factor happen. So I'm looking at my two factor trees kind of here at the bottom. These two pieces that I'm grouping in blue. I have 2 2s here, and I have 3 2s on the other one. So I got to take all 3. You have to take it the most amount of times that you see it occur. So I want to take all 3 2s. Then you also have to take any other numbers that you see happening too. So even if they don't share numbers, like they share the 2s, this one has a 3 and this one has a 5. They don't share a 3 and a 5, but I still need to take it. So I still need to grab 3, and I still need to grab 5. Then you multiply that. You take 2 times 2 times 2 times 3 times 5. That's going to leave us with 120. So that's LCM. That's least common multiple. That's the smallest number that 12 and 40 could both multiply into or become multiples of. The last thing is the greatest common factor. Okay, greatest common factor would be the biggest number that can divide into the numbers that you're working with. Okay, or it's the greatest factor that goes into all of them. So again, we're going to have to write out our factor trees, but this time instead of taking the factors the most amount of times that you see it, you only want it to take the least amount of times that you see it happen. So it's kind of the opposite thinking with the least common multiple. So on that last example, I would have only taken 2 squared. I wouldn't have taken 2 to the 3rd power. So you got to kind of reverse your thinking a little bit. In this case, they're going to give us 3 numbers that we have to do this with. So I'm going to set these up the same way. I'm going to find the prime factorization for these 3 numbers. Okay, so what are 2 numbers that can go into 15? Okay, both of those are prime. So that one's already factored for us, 3 times 5. How about 30? 15 and 2, 3 and 10, I heard someone say. 6 and 5 would also work. How about 10 then, because 3 is prime. So 5 and 2. So this one I have 2 times 3 times 5. And how about 45? 9 and not 6. 5. And then 9 becomes 3 and 3. All right, so now what we do is we go and we look at these numbers and we take the least amount of times that we see factors, but they can only be factors that they share. Okay, so in this case, the middle number, 30, has a factor of 2, but none of the other ones have a 2. So I'm not going to pull 2 because it's not shared. Now they all share 3 and they all share 5. So I only want to take 1 3 and 1 5. So you only take what they have in common, and you take the smallest amount that you can. So to find GCF, we're going to take 3 times 5, which is going to be 15. So 15 is the smallest number that can go into 15, 30, and 45. So we've got one more here. 10, 12, and 13. How do we factor 10? 5 and 2, 12. And then 4 would be 2 and 2. 13 is prime. So it'd be like 1 and 13, which really doesn't do a whole lot for us. So if I look here, I've got 2 times 5, 2 times 2 times 3, 1 times 13. I don't see any right off the bat of numbers that they share. Do you? But I want to ask you a question. I wrote 13 as 1 times 13. Could I do this? 1 times 2 times 5, 1 times 2 times 2 times 3? I could, because 1 is that magical number that can go into everything. So the greatest common factor for these 3 numbers is actually going to be 1. 1 is the biggest number that can go into all 3.